Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at radioactive decay and half-life. Half-life is the amount of time it takes for half of a radioactive substance to convert to a stable substance. For instance, carbon-14 will convert to nitrogen-14. Carbon-14 is used to determine how much time since a living thing has died by measuring its percentage, what percentage of its original carbon-14 remains. So all living things contain carbon-14 breathing in the atmosphere. When that living thing is no longer a living thing, the carbon-14 starts to decay into a more stable isotope, nitrogen-14. And it takes 5,730 years for half of the carbon-14 to convert. So we want to use our exponential model, y equals y sub 0 e to the kt, to come up with a model for carbon dating. Then, in a later problem, if we can see what percentage of the original carbon-14 remains, we can figure out how much time has passed since that individual was living, that living thing was living. Y sub 0, y, k, t. We know that we don't know the original amount. All we know is that it takes 5,730 years for it to cut in half. So whatever y sub 0 is, it will end up being half of that. And we can use this to figure out what k is. So y sub 0 divided by 2 equals y sub 0 e to the kt power. We'll start by dividing, t is that 5,730 that we have. Divide both sides by y sub 0. The left side is 1/2. And that's always going to be the case. 1/2 equals e to the k times 5,730 power. Take the natural log of both sides. The natural log of 1/2 ends up equaling k times 5,730. Finish by dividing over that 5,730. And now we turn to the calculator. I'm going to use the fraction, but feel free to use 0.5 instead for 1/2. Function, natural logarithm, back to main, 1 divided by 2. And then we're going to divide that logarithm by 5,730. Notice it gives me the answer in scientific notation. That tells me that 10 to the negative fourth, that I need to move the decimal point 4 places to the left. So one place gets it past the 1, the other 3 places insert zeros. So this is negative 0.000, 3 zeros, 121. So that's the exponential decay constant. Now we can use this new model to find out how much of the carbon, how old the bone is that has 40% of its original carbon. So I'm going to write y equals y naught e to the kt at the top. I'm going to write those variables down the side. I'm going to write down my value for k. Y naught, I don't know how much there was to begin with, but I do know that there's 40% of it left. And we'll solve for t. 0.40 y sub 0 equals y sub 0 e to the negative 0.000121 t. Divide both sides by y sub 0. And we're left with 0.4, or 40, equals e to the negative 0.000121 t. Natural log of both sides. gets us to natural log of 0.40 equals negative 0.000121t. Divide over that value of k. And now we've solved for t. We just need to go to the calculator to approximate it. Here we're talking about years, so we'll round it to the nearest whole number. Function natural logarithm back to main of 0.40 divided by negative 0.000121. And rounding to the nearest year, that's 7,573. So the bone is approximately 7,573 years old. That's it for radioactive decay and half-life. We'll come back with one last application for this section.